Day 14, extended polymerization. Now, I don't know what polymerization is, but I've written a computer program to do it, apparently. This is a polymer template, and below are rules. So as you proceed through the template, looking at pairs of letters, pairs of adjacent letters like NN, you look for a rule. Here's NN. This rule says to insert a C between the pair NN. The other rules say similar things about other pairs. And we need to go through 10 times for the first half of the puzzle, and then 40 times through the second half. Now, the way I solve this is too slow to get to the second half. I can run it and I can get up to about 20, 25, 26, 27, and then it just takes so much memory and so much processor that it just bogs down, and I don't think it would finish in the lifetime of the computer or me. So I'm still working on part 2, but for part 1, let's look at my solution. The data looks like this. There are 2 sections that are separated by double new line. So that's why we fetch the data into 2 different groups. I think I'll just debug this so you can see. And I also want to work on the test data. So the polymer NNCB, and then we're about to, so rules lines looks like all the rules just separated by new line, but if we split on new line, and then for every line we split that on space hyphen greater space, turn that into a tuple and feed it to a dictionary, then it looks like this. Let's see if we can get down to here. Okay, so rules is now a dictionary, and it encodes everything from here. CH, insert a B. HH, insert an N, and so on. Looks like it's even in the same order. Okay, then we print the polymer in the rules, and they come out here. Here's the polymer. Here's what a dictionary looks like when it's printed. So that's all good. Let's run the program now from the beginning. We have a breakpoint down here. We're going to call process polymer with an argument of 10. We want to have 10 iterations. First, we make a copy of the template, NNCB, and we're going to be modifying it here in this loop. And now, one time for each iteration, we're going to use string IO to build the next polymer. They get quite long and a lot of updates to it, so I think this will be more efficient than just using strings. Strings are immutable, you can't change them, you got to make a new string each time you want to modify it. So here we've created the string IO object, and now we're going to get the very first pair. So the first pair, NN, came from here, NN. Do we find an insertion rule for NN? Well, we should find a C here. There it is. So we write that C to our output string IO buffer, and then we write the right part of the pair, RIGHT, and then on to the next pair, NC now. And when we're done with this loop, we'll be here, and then we need to get the value that we've been building up in the next polymer string IO. And now we have growing polymer. Looks like this. NCNBCHB. This. So very good. That works. And then the loop will continue and do the other iterations. We'll do some printing. I'll do another breakpoint when we get down to here. Okay, so what did we print? We printed the step number, 1 through 10, and then the length of the growing polymer, just to kind of watch how it grows. They get astonishingly long when you get up to 20, 25 steps. Okay, so we've done everything. And now we're supposed to subtract the number of occurrences of the least frequent letter from the number of occurrences of the most frequent letter. So first we get the counts, and here we have 865. Well, maybe we should look at, well, it doesn't exist anymore, so we can't. Anyway, we're using the counter class to count the number of each of the letters in the growing polymer. So we count up the number of N's and the number of B's and so on. And we don't care what letter it is. We just need these numbers. So we sort the numbers. So watch, these are going to change the order when I advance one step. So now they're ordered from least frequent to most frequent. And then we just have to subtract the 161 from the 1749, and that gives us the answer 1588, which is what we expect for the test data. I'll just show you what it looks like if we try to run this too slow part. If we try to do it more than 10 times. So we run, it's pretty fast, 19, 20, 21, 22. But this is the length of the polymer now. And you can see it's getting really slow. So I don't think that's going to make it all the way to 40. I got to find a better way. See you next time.